Hello, I'm Ting. I'm going to describe how a PWM control solar panel works. Here without the LED, the solar panel voltage is around 1.6 volts and the battery volt is 12 volts. But when we shine the LED on the solar panel, ideally it becomes 24 volts. But when we charge the battery, the solar panel will become 13 volts, but it's still higher than the battery voltage. So the solar panel will charge the battery. So let me show you how much the voltage the solar panel has when we shine the light on. So now you can see the solar panel voltage is like 13.2 volts and then the battery volt is 12 volts. That means the solar panel is charging the battery right now. Okay, now I will explain how a PWM works. So when the solar panel voltage is much higher than the battery voltage, we will have a -5% PWM control the charging speed. It will be a very high charging speed. But when the voltage of solar panel is closer to the battery voltage, we will have only 25% PWM control. So it will be a lower charging speed. So when we see the light shining on, actually the voltage of solar panel and battery is quite close, so it will be a slower charging speed, but at the same time you can see our output voltage. Our output voltage is 0. It's because of the PWM control. So when the solar panel battery is higher, we are only charging the battery. We are not going to power the applications. But when the solar panel voltage is lower, so the battery will power the application. So you can see the voltage of current is. So the current voltage is 13 volts, which is the battery voltage to power the application. So without the LED shining on the solar panel, the voltage of the battery is actually 13 volts, around 13 volts. But our application voltage is around 5 and 9 volts. So we are using linear regulator to control the output for our application. So now we are testing the 5 volts power supply. Now you can see your output voltage is around 4.8 volts. Then now let's test another one. So okay, you can see it's around 9.0 volts.
Okay, we are doing a solar panel. Now what I'm trying to do is, using a light dependent resistor, we are going to adjust the solar panel direction based on where the sunlight comes from. So I'm going to do a demo now. After I've calibrated the light dependent resistors, depending on where the sun is, I will turn my solar panel. Okay, now what we're going to do is we're going to test the solar panel based on where the sunlight is. Suppose the sun is on the right, the solar panel will turn according to the sun and go to the right. Suppose the sun is on the left, the sun will turn according to the left. So this is our solar panel.
Hi, I'm Nishard. So as Shou has shown before, our setup can step down the voltage from the solar panel to the battery and from the battery to the load. So from the battery to the load, we're using a linear regulator to step down our voltages. So we can theoretically step down our voltage from anywhere between 0 to 12 volts. So one of the applications we have is that we want to charge a solar battery, or we want to charge a phone battery. So I can demonstrate by plugging in the charger to the port here, and you can see that the voltage is around 4 volts and the phone is being charged It says charging there. So the voltage can be, I can change the voltage to any desired one I want by changing the potentiometer value here.
I'm Heng. So after Nishard has introduced the handphone charging device as an application, I'll be introducing to you our primary application, which is the fairy lights. So in this example, we have 4 chains of 12 fairy lights connected in series. So there are 48 bulbs in total, and the rated voltage is 12 volts. So as you can see here, we have connected a 1 kilo ohm resistor in series to the fairy lights, and this is essential because we need to prevent open current spike from destroying any of the lights. If even one of the lights are destroyed, then the whole chain will be useless. Yeah. So next we'll be going to the pathway over there to show you how it can light up the pathway. So we are here at the pathway, and as you can see, the lights are lighting up the path quite nicely. And so this will be very good. Like someone with night blindness walks up the stairs that's brightly lit and enters this dark space here. When they are momentarily blinded, this will help them locate where the path starts and ends. Yeah. So, for example, here.
Bye-bye.
So yeah, would you buy this product and find it in the market, knowing that it costs like $50?
I think it should be able to, okay, because this solar panels is something that's rather sought after, but the long term is actually very expensive. So you're able to price it at $50 for such size, right? And it's able to move with respect to where the sun is. I think it's actually quite a good deal, and I would definitely buy it. Yeah.
Guys, what do you guys think about the project?
I think it's quite cool that because the amount of energy that the Christmas light uses is not a lot, so just using from our normal pots is probably not efficient. So using solar panel is a better idea. Yeah.
Singapore's weather is very hot.
So you guys see yourself using this? I mean, if you get something like this for like, let's say $50 on the market, and you know you could use it like 12 year, any kind of year, do you guys see yourself buying it?
How much is it?
Let's say assuming $50. Let's assume $50.
I think currently the Christmas light how much is? Let's say
As in for this setup, like for the solar panel and the sun tracking, and solar charging, all of those.
for me, because for me I'm not sure whether currently I'm not sure whether the solar panel, as in because most of the time your Christmas lights only need for at night rather than in the day. So I'm not sure as in if it's able to store it. Most of the time you will only be storing in the day, and then at night then you start using up. So and including for phone as well, most of the time you need to charge it at night. So yeah, that's what hopefully if that's possible I'll definitely get this product. So yeah.
So guys, what do you guys find unique about this product?
That it's able to change the output voltage, not sure the normal power. Can you do that?
Some can, but most of them don't right now.
What's the maximum voltage you can get?
Maximum voltage is 12.
I also find it ideal of charging your phone at the same time. Right?
How about the sun tracking system?
Yeah, that's also pretty awesome. I think like it's something recently explored well. Moves in directions and that's really awesome. Very cool idea.
But how much does it move? Just moves.
Around 30 degrees in the
So it's like they can track the sun the entire day, right? That's
Yeah.
So okay.
we have like two light dependent resistors on the side. So there's like more sunlight here, it will tilt like that towards us.
It's actually great.
It's okay.
Thanks a lot, guys. Bloopers!
I suppose the sign's on the. Oh!
I mean, I think solar panels is something.
Where they will be like blinded momentarily because the eyes cannot adjust to the darkness. So this will be very helpful in